Can you hear me now?
Yeah, hi Amarachi, you're welcome.
All right,
Good
all right.
evening. Yeah,
I believe.
welcome.
Thank
We
you.
are good. So we are live right now. I was waiting for you to join the stream. That was why, yeah. So we are live right now. I believe people can now watch us on YouTube. So we are live on two platforms, YouTube and LinkedIn currently. So yeah. Um Thank you very much and welcome to this session today. So, guys, this is Introduction to Blockchain and Web3 by Amarachi Ugwu. And this is the first class, which is the first class of this series. So, for the next 7 weeks at No Syndicate, we are No Dub Syndicate. We will be taking you through the process of becoming a No Dubs engineer. So, hi Amarachi, thank you very much. Welcome to today's session. Would you like to introduce yourself and then we get started from there? So let me know
All
when
right.
you okay. I have your slides with me. Anytime you need them, I can put them up. Yeah.
Yeah, you can just put them up now.
Okay, okay.
Okay. So while you're doing that, I'm just going to go further to give a brief introduction about myself. I think I have a profile section in the slide. You can go forward in this slide. Okay, yeah. So basically, my name is Amarachi, and I'm the co-founder of DigitPay. Can go to the next slide. I'm the co-founder of DigitPay, and I'm also a blockchain engineer and educator. So which means I've been writing code for quite some time now, and I love to educate people, which is basically what I'm doing now. And over the course of the years of my experience, I've basically mentored a number of individuals, basically in the field of software engineering and blockchain, likewise. So currently, I'm building a product called DigitPay. You can check that out on DigitPay. There's finance, and basically, it's a Web3 product. To cut it short, is like you all pay your money points, but it's your crypto. So basically, in my free time, I contribute to open source projects, sometimes blockchain, sometimes just normal Web2 open source projects. And then as a women technical ambassador, I'm a very good advocate of more women in tech because I used to miss my beautiful ladies in tech. So that's just like a brief introduction about myself. And I think we can start the whole session proper from now. Okay, so I think I should just proceed. So what we are discussing today is blockchain and the fundamentals of blockchain, which is very crucial if you're someone that wants to dive into blockchain, whether you just want to just have a knowledge of blockchain, or you want to go into it proper to be a programmer or an auditor and all of that, you need the fundamentals of blockchain. You can go to the next slide. So I think I'm going to start with explaining what the blockchain is, even before we get to the evolution, right? So blockchain, like it starts, I think I'm going to more like tell a story because I love telling stories, so that people that I am talking to my audience basically understand it. So let's take this for instance. I used to work in an on-site environment, right, where basically they take attendance of when people come into work and when they leave from work. And then if you default that, if you come late or you leave earlier than you're supposed to leave, there is a penalty to that. And if you keep to coming early and also staying through the hours of the time that you're meant to stay in work, you're also going to be credited for that, right? So the penalty is always a deduction in your salary, while the credit is always like an appreciation in your salary, right? So in this business, there's basically like an attendance sheet where there's an attendant. When you come in, you check in with this attendant, the records when you came in and when you leave, right? And but then there is this particular latecomer, perpetual latecomer that always is in a good rapport with the attendant that can always give the attendant one or two things and then he can motivate when this person comes in and leaves. And at the end of the day, they get the reward of the person that comes early and leaves when they're supposed to leave. And that's not fair. We are all going to like really believe, we're all going to accept that that's not fair because there's these other people that are keeping to coming early and then staying through the hours, but they don't get it. So owners of this business, they kind of like realize that such a thing is happening and they're like, how do we solve this? How do we get to the point where we make sure that the right person is getting the reward, right? So they basically talked to other business owners, and they're like, there's a solution to this, right? There's this thing called the blockchain where you can basically have your records there and then such a thing can happen. So how do this business basically adopt blockchain, right? It simply means that they have a single point of failure. What I mean by a single point of failure is that they just have this one ledger, this one book where they record all of these things or the um, attendance of the employees, right? But then once this person that is in charge of recording this thing is compromised and they change the time someone came and went to leave, it means there's a problem because once it's changed, there it's totally changed, right? The book is the only source of truth. And then whenever they get this book, they get that this person, which is the wrong person, is the person that came early, while they are not, right? So, but then when this business now decided to adopt the blockchain, then I said, okay, we're going to do this thing where we have like a network, right? Where every employee has their own ledger, right? They can enter when they came in to work and when they leave. And then it is a network because other employees have the right to kick against if a particular employee is fraudulent or a particular employee is trying to lie that they came in when they didn't come in and they leave and they left when they didn't leave. Other employees can like, okay, see what this guy is trying to do and kick against it because they're in a network, right? And they have a shared data. And then one good thing about it is that when one good thing about it is that when um, when a particular employee records the data in his or her own ledger, every other person, right, sees this record. They're more like they're in sync with each other. And then when they see it and like, no, it's not true, and they kick against it, then it don't get accepted. That way, they can they can be able to keep the actual record of what is happening. So this story that I just told you, it didn't actually happen to me. I just came up with it just for you guys to really understand where I'm going and how blockchain can be very important in solving some problems. So in the actual sense, what is a blockchain? Blockchain is a distributed ledger, a distributed database. So I'm going to pick distributed. So distributed in the sense that it is not sitting one place, just like that attendance book that was sitting one place and this attendance code multilates it. A blockchain, it doesn't sit one place. It is distributed in the sense that it is in a number of places. And the one good thing about it is that even if you go to one place that it is and change it, and then feel like every other person should accept whatever you change, when you submit that record and they're like, we don't recognize this didn't actually happen, they will kick against it. So it solves that problem of a single point of failure. It is distributed is in a whole lot of places, right? So it becomes secure and immutable in the sense that once something is recorded, once a particular record is put into the blockchain and it is accepted by the people in the network, the nodes in the network, then you coming back again to go to that record and changing something and then bringing what you've already changed to the blockchain for them to accept. They will say no. And that way we have a secure, immutable ledger, which is the blockchain. So another key word there is the database, right? There's no doubt that the blockchain is a database. What is database? Data, pieces of information is put together and the base where they are based, right? Which is basically a database. So the blockchain is basically a distributed database that is in a couple of places, and it is a distributed database is in a couple of places, and then it's a database, right? So that what basically gives us that name, the blockchain. So with that said, the next thing that we're going to be talking about is how did we actually come about the name blockchain, right? Did we just um, wake up and just say blockchain? Where the name blockchain came up from is basically from the fact that um, there's a way that this data is being stored in the blockchain, right? It is stored in blocks, right? So think of these blocks as, think of it as a carton of biscuits, right? So I'm trying to use something that all of us know, right? Think of a carton of biscuits, and in a carton of biscuits, you basically have biscuits stacked into it. And when these biscuits, when you keep stacking biscuits into a carton, it gets to a point where the carton is full. What do? You just seal the carton and keep it aside. Then you get another carton, an empty carton, and start filling it with biscuits. So think of it this way. Um, these cartons are the blocks, and it is the container for storing data in a blockchain, right? And then these biscuits that are inside these blocks, they are transactions. They are basically actions that has been accepted and recorded in this blockchain. So that basically comes about the name block, right? So now we are going to the chain. How did the chain come about? The chain basically came about because once a particular block is full, it is sealed and then kept aside. And then another block is being begins the process of getting full. Once that one is full, it is linked to the previously full one. So basically creating a chain of blocks, right? A full block is there, another one is full. That one that is currently full is linked to the one that was previously full, thereby creating a chain of block, which came about the name blockchain, right? So I believe this basically explains how we came about blockchain and basically how blockchain works, how distributed it is, what causes it to be immutable and makes it more secure than the way the single point of source of truth or single point of failure that we have. So now that we basically understood what the blockchain is and how it works, right? We're going to go to the evolution of blockchain. We didn't just come in 2025 and then we heard about blockchain and blockchain is making waves. Some things actually happened for us to have the blockchain that we have today. So the first thing that happened is in 2008, there was basically a global financial crisis in the sense that it was very bad, very bad. And then what really happened in that period was that people actually got to the realization that the current financial system is rigged and it doesn't favor the common man. So because during that crisis, there was both financial institutions and average persons were actually affected. But then something happened. There was a program that was issued out for these big companies, right? Banks were given like a relief programs. They were issued billions of dollars, right? Think of it this way. Let's bring it home, right? Think of it this way, where there is a very very bad financial crisis in Nigeria, and then everybody is down to red. Everybody is like in a financial crisis. Let me say you had 100 million in your accounts, then you're like seeing it's not like you have nothing, right? But then the government came up with a relief program where these banks are bailed, right? They are issued billions of dollars to basically stay in business to like manage their losses. But then the common man, let me say you that have an account with this bank, your money is gone, right? And then after this bill, we are actually issued to these financial institutions. They basically gave a huge credit to the top guys, the investors, the owners of the bank. They gave huge credit to them. But then the common man kept suffering, right? The common man is in red. The common man is losing jobs. The common man can't afford certain things. There were literally scarcity of jobs. Even when you have jobs, they pay you like very, very low and all of that. So that was when people now got to the realization that this is not fair. Because what it simply means is that when things are going low, these banks task us, they charge us for giving us a certain service. But when everything goes right, the government comes to their rescue and we are all on our own. We are left to suffer, which is very bad. So people actually come to this realization that there has to be something. There has to be something that can bail us out. Then, even prior to 2008, there has been revolutions trying to preach a kind of a decentralized digital financial system to people. The people were not really getting it because this haven't yet hit them. But then when it hit, luckily for Bitcoin, Bitcoin was ready at that point, right? Bitcoin launched and it was like a savior to this situation because in that case, Bitcoin came to the rescue that you can actually own your money and you own your money and you can wake up tomorrow and like, yeah, beat your chest, I still have my money. Unlike when you have your money in financial banks and if the bank goes bankrupt, you basically the chances of you getting back your money is very low, right? So you wouldn't want to be in that situation where you're not in control of your money. That's why Bitcoin actually flied. And prior to Bitcoin, there have been other inventions like hash cash. There was Bitgold, right? Bitgold came in 1998, but it has a timing issue because, like I told you, in that 1998, things were going well. People didn't really understand why having a platform like Bitcoin was important. And he had a couple of issues. He had computational power issues as a time. But then Bitcoin was actually what people needed in 2008. And when it launched, people really embraced it because of the current struggle that the current financial crisis has cost people. Right after Bitcoin, people started like realizing, yeah, this is a really cool invention. Then in 2013, Ethereum came about, right? Bitcoin was more like a store of value where you can just basically store your money. You can either store your money there or you can just use it for P2P exchanges. You can just use it for sending somebody some amount of money to get a certain value from them. So it was more like just a digital gold, right? It's either you're storing your money or you're making a P2P transaction. But then Ethereum saw like more feature to the blockchain. Ethereum came about and it was more like a programmable blockchain. And what does this really mean? It meant that blockchain is no longer limited to only storing value and then making transactions. We can actually build applications on top of the blockchain. So then it started getting more interesting, right? Because this in that world that people were like still doubting, are we sure? We're not sure. Now came with a fresh face where more possibilities. We can build apps that can work on the blockchain. And then it started making sense, right? So it kept evolutioning until um, it kept evolutioning until 2020, 2015, right? Um, Companies now start seeing that, okay, this is actually something worth looking into, right? Big companies started forming consortiums, trying to look into blockchain, trying to see how can we adopt blockchain? How can we, is this against us or is this for us? Let's see how we can start adopting this thing into our system. Let's basically not get left behind. Then some adoption came through, but then in 2017 we saw like a boom in initial coin offering. This is basically let's take it. You have an idea, right? And then you're basically getting people to pledge on this your idea that it will fly when you launch, right? You basically issue a certain token, just like saying, I have this idea and I believe that it's going to fly. And I want people that believe in this, my idea, to kind of issue me a level of money. And this money they're going to issue me is going to allow me to bring this my idea to life. And when this my idea comes to life, if it flies, you get a certain percentage. Most times, it's always greater than what you put in. It's more like an investment, right? So it actually came to a high rising where people started embracing it. People, instead of the way normal way where you pitch your product to a VC and they give you like a fiat cash. But then ICO now came, people just mint digital currencies through the help of smart contracts, and then people can actually invest through buying these coins. So we saw that rise, and there were a lot of crypto projects that took off then, and there were a lot that crashed. There were a lot that were fraudulent in the process, right? So, but then this was like a very huge upside for crypto because we saw another level of possibility with ICOs, right? Then in 2020 came about DeFi, right? DeFi basically was, we are now like, okay, now that we have a level of breakthroughs in blockchain, we want to get to a point where we can model the current financial system that we have, like the banks, the way the bank works, the way the broker works. We want to be able to do the same exact thing on the blockchain. That was basically what DeFi was all about. We want to be able to do borrowing, do lending, do saving, do all of these things that you can do with your conventional banks with the blockchain. That was the whole boom about DeFi. Then that actually met a level of breakthrough and it is still progressing as we are speaking. DeFi is a huge market as we speak. Then in 2022 came about metaverse and NFTs. I don't know if anybody like if you caught this period in time, it was very, very massive and huge, right? You can go to platforms like OpenSea and then you can see an abstract art selling in thousands of dollars. You can see just a simple clip of video, maybe a 6 seconds video, a 30 seconds video selling thousands of dollars. There were things like CryptoPunk. There were a lot of NFTs that really took off and what like the market cap was like in millions and billions of dollars. And that was actually crazy because it was another level of possibility that we never knew existed. And there was the metaverse where you basically can model what is happening in the real world in the air, basically, right? So this was another level of possibility for us that we saw with the blockchain. And one thing about all of these things I've said so far is that they kept progressing and they kept building on top of each other and they kept working hand in hand with each other, right? And then we came to 2023. We saw more rise in layer two. We are going to talk about that in few minutes. Basically, layer two solutions, we are giving scalability solutions to layer one blockchains that we have, right? The likes of Ethereum, Bitcoin, Litecoin was basically giving it because most of these layer one blockchains we are more like had scalability issues. They were slow. They had high gas fees. There were just basically a few things that weren't just that needed scaling. And then there were more rise in these scalability solutions, these layer two blockchains. We saw that more in 2023. And then in 2024, we started seeing omni chains, we started seeing protocols. 2024 was just like a few months past, right? And then we all experienced the things like you see things like Telegram mini apps, you see AI blockchain products, you see AI, you can see blockchain bots that can trade, right? But they are powered by AI. So they are just the whole AI boom, and then in combination with blockchain, we saw more of that, and we are still seeing more of that in this 2025, which we are currently now as we speak. So blockchain has actually moved a lot, right? And you can see there are still other things that came up, but these are like the ones that like stood out. And we've progressed 2008 to 2025 is a lot of years, and we have seen massive progress. So I believe that this gives you like a skim through of what has happened over the years, and you can actually get to understand that this is an ever evolving market, an ever evolving business, and then we can actually find where we can tap into it and find our feet and move on with it. So let me get the next slide. Okay, so I think the next slide is basically the what's on the next slide? The next slide is basically the three pillars of the blockchain, right? So when it comes to blockchain, we have three things that make the blockchain strong and scalable the way it is, right? strong and secured way it is, right? There is this thing called decentralization. So you can actually have some thing to do with the blockchain um, being distributed, right? So it simply means that if you're someone that has written code before and then you've deployed a product to like a centralized service, like you see things where you have to host your product in AWS, you have to host your product in DigitalOcean, or even using Namecheap hosting services, hosting leaders, you can see that this is a centralized way of hosting your products. And what this actually does is that when there's a problem with decentralized hosting service, your product is down, your application is down, you're not able to access it, or if you as even the project owner goes and take it down, it is down. But when it comes to the blockchain, it is decentralized in the sense that when you take down a single node of the blockchain, it doesn't go away. There are thousands and millions of other nodes that is actually connected to this network that is serving the network. So it is a decentralized network that it doesn't have a single point of failure, like I was saying before. And then it doesn't have a single point of control, right? Just like these other hosting services that I mentioned, right? It is distributed, it is in a lot of places, it is in a network basically, such that you can actually connect to this network and then you have access to this blockchain. That is what makes it decentralized. And the profit of this is that one person cannot just say, I don't want the blockchain to be up today and take it down. Doesn't make sense. So the blockchain is decentralized. That even when one node says, I don't want to be on this blockchain again and goes away, every other person moves on and every other thing is still working as it's supposed to. That is the decentralized nature of the blockchain. Then we have immutability, right? So immutability in the sense that, like I was saying before with my employee analogy, where once this record is entered in the blockchain, it is accepted by the nodes and entered in this blockchain. You as a single node, you cannot go and change what has already been accepted and recorded in this blockchain and then come and then um, place it for the blockchain, for the network to accept it. They are going to really dictate that there is something wrong about this your record. And they're going to see that you actually made some mutilation and they're not going to accept it. Right? That brings about the immutability of the blockchain such that once something has been accepted and recorded on the blockchain, you can't just come and change things and go scot-free. You can't just do that. Right? Although there's something called 1% attack, where more than 50% of the blockchain agrees that we want to get this changed. And then if that agreement has been reached, if that consensus is reached, then that change can happen. But you um, as a single node, you cannot just come and say, I don't want to, I want to change something, and then you just basically change and then allow expect the blockchain to accept whatever you want, right? So it is immutable because making this change is almost impossible, right, as a bad actor. But when it is like a consensus reached by the nodes in this blockchain, then that can happen, right? So it is transparent in the sense that um, you can actually basically visit the explorers of this blockchain and you can see transactions as they happen. You can dig into these transactions and see how much was transacted and which address or which account received this amount, how much was transferred, how much was paid for gas fee. You can basically inspect and see every details of a transaction, which makes it transparent. This is unlike what you can do with your traditional finance system like your banks. You can't just go to a bank and then say that I want to see your database. I want to see I want to see there's this rich man in my community. I want to see how much he has in his account. I want to see it. I want to know the last transaction that you made. You can't do that in a conventional banking system, basically. But you can actually do that in a blockchain. You can basically go and see who sent money and who received it, how much was transferred, how much was received. You can see all of these things and it is there, and that makes the blockchain transparent. So next slide, please. Okay, So, so the next slide, about layer one and layer two scaling solutions, right? Layer one, just like the name sounds, is the base layer of the blockchain. The likes of Bitcoin is there, likes of Ethereum is there. But like I said, these blockchains, they have some issues in the sense that needs scaling, especially when some of the issues is like they have high transaction fee. Just think about that. You want to transfer $100 to somebody, and then you're paying as high as $20 to transfer $100. That is quite high, right? So this is a problem, and it basically discourages people to use the blockchain because if you're charging me up to the amount to make such transfer, then I might as well consider using some of these other um, conventional financial solutions. But then layer two solutions come to the rescue, right? They come and like basically provide a level of scalability to this layer one blockchains, and then do their own do their own work by handling some of these transactions, batching it as they are supposed to. There are several layer two solutions that operate in different ways. There are roll-ups, there are optimistic roll-ups. There are several of them. You can see from the image here, we have optimism, there is arbitrum, there is days, and there are a number of it, and they basically help reduce, they can reduce transaction fee as low as cents. Think of paying as high as $10, $20 in platforms like Ethereum or Bitcoin, and then you can pay as low as cents in some of these layer two solutions. It's a huge progress for us, right? It makes adoptions even much more easier. So basically, layer one is the base chain, and layer two is the chain that is here to help with things like high transaction fees and also processing time. So there are times when if there is a huge amount of pressure on some of these layer one blockchains, you can see that transaction can take as long as 30 minutes to 1 hour to complete, as opposed to some of these layer two solutions that take less than a minute to complete. So you can see that these solutions are really crucial and needed in the blockchain. So they basically provide these solutions to help in the adoption of blockchain by solving problems like high transaction fee and then processing time. So next slide, please. Okay, so um, I think before the next, this we are just basically going to go through architectures, but then I think I will basically kind of get you to understand how some of these things works because I tried as much as possible to basically make this more relatable since I learned that the audience is more of Nigerians. So we have several blockchains. As we speak now, there are about 1,000 plus blockchains across the globe, and this encompasses um, both private blockchains, public blockchains, hybrid blockchains, even consortiums. So I think I'll just shed a little light on that. So when I talk about public blockchains, so the likes of Bitcoin, Ethereum, Litecoin, they are in this category where it is public, like it's totally public. There is no level of centralization to it, where it basically is 100% decentralized, is 100% transparent, and is 100% immutable, right? So everybody has the same level of access. Everybody has the same level of authority when it comes to um, this type of blockchain, right? So, but when it comes to public blockchain, just like a private blockchain rather, when it comes to solutions, private blockchain, just like the name sounds, it is private. So, not you are just you. If you're not invited, if you're not a part of this blockchain, then then um, then we are going to have a problem, right? So what I'm basically saying is that for private blockchains, they are basically private. They are a confined blockchain. You can't just come like public blockchains and start inspecting transactions. That is private blockchain. So when it comes to consortiums, is since like they just basically came to like make private blockchain a little bit, because when it comes to private blockchains, you can see things like it is more prone to fraud because these are just like a few persons have the highest authority and they can actually mutilate things. So it then came up, they now came about things like consortiums where it is still private in a way, but then it's now owned by a couple of organizations. It's no longer owned by a single party. It's not owned by a couple of organizations, and they now have the way they operate. They have their rules and constitutions, right? And when it comes to hybrid, it's more like partly private and partly public, right? There's a level of privacy to it and there's a level of publicity to it. So not everybody has the same access. So with this basically make up the types. This basically all these different blockchains that are in existence today have the ones they belong to. So when it comes to the analogy I have here, I have Ethereum as a case study. I have Bitcoin, I have Polkadot, I have Cosmos, and I have Solana. So think of Ethereum like a Nigerian university where um, it has a sophisticated infrastructure where you can build upon, you can build apps on top of it. But then think of Bitcoin like just owning a land, right? You can basically leave it to appreciate as a store of value, or you can basically sell it off to make some money, right? It doesn't have a computational power to carry applications. Then Polkadot is like a network of Nigerian investors. Polkadot is more like it's an ecosystem that help you build your own blockchain on top of it, right? It provides some level of security and communication, but then you can build your own blockchain on top of it. And then you can in turn collaborate with all the other blockchains that are built in this ecosystem. Then for Cosmos is more like in just like I said, it's more like a Nigerian state where each state basically governs itself and can trade on their own. So Cosmos basically gives you some level of gives you the liberty to build your own blockchain and also provide your own security. But Polkadot's more like provide the security for you and then lets you build the blockchain. Then Solana is fast and is efficient, but then it's functions in such a way that it fosters um, fast transactions, right? So think of it like the Okada and Keke Napep. You know, when you're in traffic, you can basically use an Okada to navigate traffic so easily. But then when everywhere is just when everything breaks down, then it's clutched up. But then it basically makes fosters very fast blockchain. Right. So with this explanation, I think you can better understand the next part of the slide, which is basically trying to go a little bit more in depth in the architecture that we have on this blockchain. So I think give me the next slide, please. Okay, so this is just basically like a key point of what makes this architecture different and the way they actually work. So for Bitcoin, we have proof of work. So the way proof of work works is that for you to remember what I was telling you about blocks. So blocks is where transactions are being stored and then in turn they are chained. So for a block to be generated, there's an amount of work that is needed from. There are people called miners in the Bitcoin blockchain. These are the people that validate transactions, there are people that confirm transactions, that process transactions. And among the miners, for a new block to be created, so once a block is full, a new block has to be created, right? So for this to happen, there has to be a proof of work, right? So there's something called block difficulty in the Bitcoin blockchain where there's a hash that is being generated and then miners across the globe have to solve complex mathematical problem to provide a particular hash that has that is lower than the current block difficulty. And once a miner gets that, he basically broadcasts it to the network and says, "Oh, I found this." And if depending on the person that finds it first, then the block is generated, and then these miners are rewarded for generating a block. So we basically use a proof of work system, and this is basically how it works, right? And it is monolithic in the sense that it just has a one layer where everything happens, right? So that is basically what monolithic means, right? So for the Bitcoin blockchain, it uses proof of work, it functions with miners, and it is monolithic, right? Then going forward to the Ethereum blockchain, there is also what we call proof of stake, right? Where instead of miners now that we had in the Bitcoin blockchain are replaced by people we call validators. And validators are chosen by, you have to have stake an amount of Bitcoin, of Ethereum rather, for you to be a validator, right? So once you stake this amount of Bitcoin, then you can validate transactions, you can confirm transactions, and all of that. That is basically, and then the reason for staking for this in the Ethereum ecosystem is so that if you as a miner, if you as a validator rather, decides to validate a wrong transaction or basically be a bad actor, your stake is actually at stake, right? So there are chances of you getting your stake slashed or even getting your stake away from you if you validate a wrong transaction or a fraudulent transaction. That is how the Bitcoin and the Ethereum architecture work. And then Ethereum has something we call smart contracts. And these are basically digital contracts that can basically run on their own as long as the certain conditions are being met, right? So this is possible because there's something called EVM on Ethereum. It's basically a computer that is embedded in the Ethereum ecosystem that can run your smart contracts, right? It can run your smart contracts. Yeah, and it's also monolithic in nature in the sense that it has a single layer of operation, has a single layer where everything happens. So when you now come to Polkadot. Polkadot has also works with smart contracts, but it has something called a relay chain and a parachain. Just like I said before, Polkadot lets you build blockchain on top of its ecosystem. It's more like the relay chain is like the mother chain, and then the parachains are like individual blockchains that are built on top of this blockchain. And then the good thing about it is that these blockchains can communicate with each other. So the relay chain handles the security for this other blockchain. It handles the security and it also handles the communication between these blockchains, right? So if you're planning to work on a blockchain and then you figure out that you want to have a level of communication with other blockchains, and Polkadot is actually a good blockchain for you to consider. So for Cosmos, Cosmos is slightly similar to Polkadot in the sense that it accommodates multiple chains on its ecosystem, right? But in this case, it is more independent in the sense that it lets you handle your security, it lets you handle your is much more independent than the Polkadot ecosystem. You handle your blockchain and your security for yourself, right? So when it comes to Solana, like I said, Solana is a fast blockchain, and the way Solana works is that it does something like it uses proof of history. Proof of history is it basically timestamps transactions before it gets validated, right? So what this does is that all these other blockchains that I've mentioned, the way they work is that when a transaction is submitted, they wait for it to be validated before they now start deciding which one to process first, how to arrange these transactions, right? But when it comes to Solana, they basically timestamp it. That means they basically arrange it already before even validating it and all of that. So this basically reduces the processing time in the sense that once it's validated, it already knows the position that it's supposed to take. And this basically is one major thing that makes it even faster than some of these other layer one blockchains. So it's also monolithic in the sense that has one layer of operation. So I think this basically gives you an idea of different blockchains and how they work and how they function. And more blockchains would come up with their own architecture to suit like a particular need. Some blockchains are more free and diverse to let you build upon and then create your own rules, and but you can also build on top of it. So this is basically what I have for today. I think this is all I have for today, and I don't know if there are room for taking questions. But yeah, I think we have
Thank you.
Precious. Can you?
Yeah, thank you very much, Amarachi. Thank you very much. I think this is like the most detailed blockchain session I've ever been to since since yeah I've been hearing about blockchain. This is like the best so far. The fact that you use like real life example to explain each and every one of them makes it like very easy to understand, right? So we are going to take questions. Um, if you have any question, please drop it in the comments. No matter where you're watching from, if you're watching on YouTube, drop it on the comments. If you're watching on LinkedIn, also drop it on the comment, and we'll be able to see it. We're going to project it on the screen, and she's going to answer the questions. So I'm waiting for questions. Anyone? Anyone with questions?
Oh, precious. Maybe. Hi, everyone. While we wait for questions, I'm just gonna talk about why we have this. Thank you so much, Amarachi. Amarachi has been my friend for a very long time, and she's one of the smartest women in Web3 that I've ever met. Thank you so much. So the reason why we have this is because we found a gap when it comes to node ops. It's something people really don't know about, and we are at the beginning phase of this. I find out that I have DevOps engineers who are very good in DevOps, but they don't know blockchain. In fact, they don't know what blockchain is at all. They just hear about it. They hear about Bitcoin. They hear about trading. You know, and then I have people on the other hand who are blockchain professionals but don't know anything about DevOps. Do you get? So node ops is actually in between node operations, right? So most of the people on this call are actually from the DevOps community, and I feel it's not just going straight to deploying. We can start deploying nodes now, Ethereum nodes and whatnot. But do you know what you're deploying? Do you actually know how the blockchain works? Do you know the history of the blockchain? Do you know how the EVM operates? Do you even use Web3 services in your everyday life? So that's why we have this, and we'll be bringing more professionals in the space to talk about it. The point is, when you go home, you should be using these things every day, understand it. When you hear buzzwords, we have the community, ask questions. All right. I think I've said too much. Sorry, precious.
Yeah, I think thank you very much for making that explaining why we are doing what we are doing. I mean, it's very important that you explain that. So there's a question on the screen. Marachi, I don't know if you can see it.
Yeah,
Yes.
I am actually seeing a couple in
Oh,
chats.
okay, okay, okay.
So okay, um, okay.
So I think we can start.
So
We can start with
basically,
the
the
first
one.
one. That one that says, "Is blockchain one or blockchains are different for each network?" Yeah.
Yeah, there are several blockchain. Like I said, there are a number, like 1,000 plus blockchain currently. So they are actually different blockchains for each network, right? So something like Ethereum has its own blockchain. Something like Bitcoin has its own blockchain. Something like Litecoin has its own blockchain, right? So these networks have their own blockchain, right? But each blockchain can have several cryptocurrencies. Something like Ethereum can have several smart contracts, right? So, but these blockchains have different blockchain. These blockchains have different, these networks have different blockchain. Any way you want to put it, yeah, but they are different. So mind pure, I guess I answered that. So so I still don't understand some parts like the blockchain set up. Okay, like the architecture. Um, yeah, like I said, different blockchain have different architecture. Some are similar, some are like basically totally different, right? So you can see the difference when I was talking about um, Bitcoin. So Bitcoin is has something called UTXO, right? It's the way that it keeps track of Bitcoin balances, right? So when you also come to something like Ethereum, it has something called accounts, where it keeps track of cryptocurrency balances, and then these accounts can actually be used to trigger transactions on the blockchain. So I think the timing for this call might not really give me the room to explain some of these things vividly, right? But these blockchains have their own architecture, and then some of these things, there might be like the need for deep dive for some of these things. Okome, I don't know if you want to say something.
Yes, yes. Like you said, there are different architectures for different blockchains and different protocols. I think the next class we'll talk about a block itself, things like the nonce, things like the transaction hash, timestamp, those kind of things. What actually makes up a block that makes up a blockchain? And like you said, this is very short, so we won't go deep into the architecture. But later on, more speakers will come in and give us more details on that.
Okay.
I
Nelson
think the
says,
next
can we
question.
get
Yeah.
traded and a bit on definitely. I think Okeme can handle that. He has a ton of it. So yeah. The next one. What categories do ICP fall on? Okeme, do you want to take that?
Yeah, ICP, that's the Internet Computer Protocol. Yeah, it's not so popular, but it's really good. I think Internet Computer Protocol is in the layer 4 category stack, um, where it's actually a peer-to-peer kind of like consensus kind of thing, message routing and execution. They call themselves actually a layer 4 or a 4 layer or something. You can do your research on that. ICP. There are many other blockchains. Uh, just do some research on that. I'm going to share materials on the community. So if you are not part of the community, please let us know so I can share some materials.
Okay, thank you for that, Ukele. So for a product manager in Web2, what roles can I explore in Web3? You can basically still explore projects, product management role in Web3. So, but the good thing about it, the one thing that I would do is get very familiar with the fundamentals, because if you don't know the fundamentals of Web3, it becomes even harder for you to manage products, Web3 products, right? Since you're a product manager in Web2, you can actually still leverage that your skill of product management in Web3. But then you still have to do a level of work for you to understand how Web3 works and how products in Web3 works, right? So you can actually start by trying to use some Web3 products, right? You can use dApps, you can use applications like Uniswap, you can try checking out some of these Web3 products, right, that does DeFi, because most you won't escape DeFi projects as a product manager. So you can explore DeFi projects, try to understand what is MetaMask, what is account, what is transaction, what is they're just little things that you need to not little things, fundamental things that you need to know for you to be able to like manage products in Web3. But I believe before this whole course exhaust, you'll be able to be able to be equipped with all of this knowledge, and then you can leverage your product management skill in Web3. So can
Thank
you
you,
hear me?
Amara. Sorry, I
Yeah.
just have to come here quick because I said something wrong. I actually said ICP is a layer 4. It's not a layer 4. It has a 4 layer stack, but it's a layer 1 protocol. right? There are many other blockchains with different things. You can't cram everything, but ICP is actually layer one.
Okay. Thank you for that. So the next question says, can you recommend a good book to grasp fundamental of blockchain technology? Uh, I think I have a number of, I think I have more of um, resources, not book, book, just books. I have some, it could be tweets, YouTube videos. So I think I'll just give that to Precious after the call so that he can share with the community. So this is another reason for you to like get um, with the community. So this other question, I think, join the community. There's a curriculum, right? So once you join the community, you can ask for the curriculum in the community. Is that the
Sorry,
point it will use?
right. Sorry, let me talk about the curriculum. So the email, the acceptance email that you got today, check it. There is a link to the curriculum. You're going to see everything, all the topics we are going to treat for the 7 weeks, including the tasks you are supposed to do for each week. So yeah, the curriculum has already been shared with you. All right, back to you, Amarachi.
All right. So doing tech, thank God you understand. Fundamental is crucial, right? So you need to get the fundamentals right because if you don't, you keep having crisis as you keep going forward. So yeah, I know you're expecting a particular one, but the fundamentals are very important. Um, are there more questions? Questions, is that all? Okay. On-chain versus off-chain computation efficiency, right? So I think this is more related to the load up thing. So, but
I
I think
wait,
Ukeme is the best person
yeah.
to take this.
Please go back.
Yeah.
What do you actually mean by off chain and on chain? Let's not confuse ourselves. What do you mean by on chain and off chain computations efficiently? If you can put that on the chat, because I actually do not understand what that means. Okay, just we can go to the next question, but let us know about that when you can explain that. Thank you.
Majority carries the vote. If the larger number of votes agrees, then that's okay. Yeah, that's basically it, right? So it's more like saying that the eyes have it, the nays, and all of that. So if there are more um, notes that agrees that this is the right way to follow, then that is accepted. But in a case where the lower number of persons trying to, the lower number of percentage cannot impose a particular um, data on the blockchain. But once there is like 51% of the blockchain accepts it, then that works. ICP is actually illegal. Okay. Okay. Is that all? Okay, so can you give us some of the protocols so terminology starts can start to get familiar with before the next class? Okay, I think the curriculum the curriculum kind of takes care of that, right? So I'm precious already said this in the acceptance email, so you already have it in your mailbox. Let's go to the next.
Hi. Okay. I think that's all the questions we have. Thank you very much, Amarachi, for answering in a very detailed manner. So
Sorry,
while I'm having difficulties to
sorry,
drop the
Precious.
link,
Sorry, Precious, please. Can you just go
okay.
back to that on chain and off chain question? Let me give it a shot. Okay, it says, okay, this is imagine
Yeah, there's a follow up.
okay,
Yeah.
imagine a big notebook, the blockchain, where every time you do math, you have to write down the problem and the answer so everyone can see it. Okay, so by on-chain and off-chain computations, I'm thinking maybe you're talking about how the entire, like when we make a transaction, what actually happens in the background. I think so. So when you make a transaction, right, there are some people called validators, right? So these validators will actually look at the transaction, and there will be a voting structure on, okay, let's just vote about how this transaction will go through, and then once the transaction goes through, they add the transaction to the block, right? So you're saying, imagine a big notebook where every time you do math, you have to write down the problem. So there's a ledger, right? It's called a distributed ledger, right? So this ledger, once you do any transaction, every other node would have access to that data, right? So once there's a consensus with that data, like everybody has already has access and they've signed that data, it can now be added to the block, right? So it's saying a follow up. This takes time and space. On chain computation is like doing the math in the notebook. Everyone sees it, but it's slow and expensive. I won't say it's slow. I would say it's expensive. Off chain computation is like doing the math on a calculator outside the notebook and only writing the final answer in the notebook. It's much
I
faster
think
and cheaper.
is this
You mean like this?
layer
You
one,
think it's
layer
not?
two. I think he's trying
It's not.
trying to say something about layer one, layer two. Is it? I think he's drifting
No,
towards that.
I think it's actually tilting towards where the computation is being done. Like you can do the off chain, you do the computation locally and then send the answer to the ledger. On chain, you do it like in, like let's say in the node itself, and then send the answer to the ledger. Do you get? So in terms of node ops, to be very honest, I can't even say anything is off chain computation. There's nothing like off chain computation, to be very honest, because you need to be running the binary that is doing the computation. If, for example, Ethereum blockchain, whether your node is on chain or off chain, you need to run that binary to do the math. So I can't really call that an off chain computation, right? Because you're actually running the binary. Do you get? I think that should explain it. So there's nothing. I don't think there's anything like off chain computation in blockchain. Everything is actually on chain. That's why it's the blockchain. Amarachi, do you
Yeah.
have anything to say there?
Yeah, I'm trying to get what he's asking from the standpoint of layer one and layer two.
Okay.
Layer two, most layer twos kind of like abstract some of the computation and then it
Mhm.
does it outside the layer one, which is
Yeah.
more mostly faster, and then they stack it, process the whole transaction, and then submit the results to the
Mhm.
layer one. So this makes things move faster, less costly, right? So I think that it has a level of
Yeah.
similarity when you say that the transaction is like off chain is like units on a calculator, right? When it comes to layer one, you see that most all this computation happens in the EVM, it happens on chain, right? So it takes computer power, and then more computer power means more transaction fee, and it means more processing power, right? But then when the layer one comes, it kind of abstracts most of these things out of the layer one, and then does most of the computation, and then the underlying stuff in the layer two, and then brings it back to layer one. And then that's Crystal's layer one, layer two stack.
Yeah. So I think the layer one, layer two thing actually does explain it. I think that better put would should be a layer one, layer two question and not really an on chain and off chain question. Because even if you are running on a layer two, you are actually running a binary, and that binary does the computation on chain. Right. So this is a follow up. It says if you are processing data elsewhere, like in the backend server L2 solution or on an Oracle, and only sending results to the blockchain, then you are doing off chain computation, which is faster.
I think the layer one, layer two basically solves this, right? So I think he's coming from a standpoint of Web two knowledge and the way the whole thing is working. But if you study layer one, layer two, basically that's basically what's going on. Like in the
Yeah.
in the surface layer, that is basically what's going on, right? Layer two abstracts computation and then basically
Mhm.
submits the results to layer one.
Then layer one. Yeah. I think that answers it. Well, I was actually coming from the node ops perspective, like because layer one and layer two, as a node ops engineer, they are both binaries. They are just binaries, to be honest. And they are, the point is, make sure the binaries connect to other binaries, and there's a peer-to-peer connection between machines. You know, yes, the layer one, layer two thing actually explanation actually does answer that.
Precious.
All right, thank you very much, Amarachi. Thank you, Okeme. Thank you so much. Thank you for making our time to come and educate us today. This is really interesting and I enjoyed every bit of it. All right, so guys, thank you everyone that joined. I think we had about 36, 37 people join the call live, and I believe other people will also be watching the recording. It's on YouTube and then it's also on LinkedIn. On YouTube, you can find it at the Node Ops guy, and then on LinkedIn, I'm not sure what the account is. So, important announcements. Next week, same time, we're going to have our second our second class. It's going to be on this same channel. If you're watching on YouTube, please make sure to follow the account, like that particular video, this particular video, and subscribe. Because when you subscribe, whenever we go live, you get to see it. So it's important that you subscribe to this particular YouTube account. All right. So the next class will be coming up next week. The curriculum has been shared. If you are also in the community, I'll drop the link to the curriculum again. So it's we have a task for this class, and the task is research and write a comprehensive comparison report on two blockchain architecture of your choice. Maybe I should let me put some of these things in the chat so you can be able to easily access them for those that are not in the community. So this is the link to your if you check the chat, you're going to see the link to the curriculum. And the assignment for week one is also I'm putting it in the chat. The assignment for okay, good. So the assignment for week one is on your screen right now. Research and write a comparison report on two blockchain architecture of your choice. So we've answered some of these things. That I mean, this question that Emmanuel asked made Ukeme and Amarachi to answer to talk about architectures in like in a deeper way, more than what was presented. So, guys, do this, write this, submit this. So when you write your article, you can publish it on any platform that you want. All we want is for you to send us the link. So if you're in the community, um, we are going to submit a form. We're going to give you a form for submission. We'll also send it to your emails, right? So um, make sure to submit. Only those that submit are those we are going to see as people participating in this program. So if you don't submit, we are going to assume that oh you dropped out or you're not interested in what we are doing, or you listen to our first class and you're saying that oh I'm not interested, I only know these things, I'm an OG, I don't need to continue. So please, if you're continuing with us, it's important that you do this because this is how we are going to keep track of what you're doing and to be sure that you're part of the program. All right. So thank you very much, everyone. Thank you, Keme. Thank you, Amarachi. I think this will be where we'll be calling it a night. So, but last words, Hamarachi, do you want to say anything to encourage our participants?
Okay. Just like I said before, fundamentals is very important, right? If you don't get it right now with the fundamentals, you're going to have crisis going on. Um, so basically, take this serious. That's just all I'm going to say. And you already having those up um, knowledge is a huge edge when you're coming into um, the Web3 ecosystem. See our organ, see us is fresh. So if you want, so if you want to be fresh like him, you have to take this serious. So that's basically what I have to say.
All right, thank you very much, Amarachi.
Thank
So,
you.
okay, but let's be fresh. Like, take this serious so you'll be fresh. Thank you. Hi, Keme,
Yeah.
our fresh Oga.
Don't mind.
Any
Don't
last
mind
words?
Amarachi. Amarachi, thank you so much for your time. We really appreciate. We'll be seeing you next week again for a more power packed session. And guys, please take this serious because there are opportunities. There are only a handful node ups, guys, in the world. And if you come in very early, I believe in a few years time, there are lots of opportunities waiting for you. Yeah. So please take this serious. Thank you.
All right. Thank you very much, everyone. Thank you for coming. See you all next week. Enjoy the rest of your evening. Bye bye.